So these are the topics we'll be taking care of as regards the SS3. We have what we call the electromagnetic waves. We have what we call the gravitational field. We'll also be looking at, under gravitational field, we'll be looking at forces of gravity. We're looking at weightlessness. We'll be looking at gravitational potentials. We'll also be looking at gravitational potential energy. They are all different topics, subtopic under gravitational field. Also, we'll be looking at what we call the escape velocity. What we mean by escape velocity. Now, another one is the orbit velocity and escape velocity, and all the formulas that are related. So after that, we go into another good topic. We talked about the electric field. Now, under electric field, the subtopics involved there are electric field or point charge. We also talk about electric field intensity, electric field flux, electric potentials. We'll also be talking about capacitors and capacitance. So enough of all that. Let's start afresh. Now, remember we said we are going to start with electromagnetic wave. The SS2 series we spoke about. We said there are two major categories of waves. We have what we call the mechanical waves and electromagnetic. Now, if you recall, under mechanical waves, we said mechanical waves deals with waves that are actually physically occurring. When we talk about waves like, under it we spoke about waves like your transverse wave. I have to do all this so that you'll be able to differentiate between mechanical waves and electromagnetic wave. So under the mechanical, we spoke about the transverse wave and the longitudinal. Now, as we proceed, then you recall that we also spoke about different properties of wave, where we spoke about the diffraction, the interference, reflection, and refraction. So let's proceed. In this series now, we're looking at electromagnetic wave. Now, this junction, we're looking at the actual meaning of electromagnetic wave and the various types or categories of electromagnetic wave. Now, under electromagnetic wave, we'll be looking at the definition right now. Electromagnetic waves are waves which can travel, you understand, through the medium of outer spaces. If you look at the mechanical waves, they require the presence of material medium. Now, if you recall, when we were defining it there, we said your mechanical wave requires material medium. When I say material medium, they need a particular material for the wave, for the wave properties to actually be transferred. Let's say, for instance, a stone being dropped in a bowl of water, the ripples will come out. What brought about the ripples? If I were to ask you, what brought these ripples? Definitely this stone. Meaning that this stone, the water itself, are the two major materials that brought about this wave to be experienced. So definitely, this wave is a type of what? Mechanical waves. Why? Because is a type of mechanical wave. Why? Because they require materials for the what? Their wave properties to be what? Transferred. But for the electromagnetic wave, they flow from their dispatch point. I call it dispatch. You get? You can use this to signify the waves. They flow from their dispatch point to what? To their destination point. Without any material involved. I'm only taking my time to do some graphical analysis so that you'll be able to differentiate between a mechanical wave and electromagnetic. So for electromagnetic wave now, they flow naturally without any material being involved or being used up for the wave particles to be transferred. Now let's proceed. Mechanical waves, unlike magnetic wave, requires the presence of material in order to what? Transport the energy from one location to another. We already said that. Now let's look at sound waves are an example of mechanical waves, while light waves are an example of what? Electromagnetic wave. From your graph there, you will see the chart as regards what an electromagnetic waves actually means. Let's proceed. Electromagnetic waves are created by vibration of what? Electrical charges. They are created by vibration. Vibration, this is the source now. The source point. Now, when the source point vibrates, it will now discharge electron. You get? From that definition, are created by the vibration of what? An electric charge. When an electric source is actually vibrated, it discharges what? An electron. So these electrons flow too could be termed as electromagnetic wave. This vibration creates a wave which has both an an electric and a magnetic component. Are we getting it now? So you need to understand what electromagnetic waves are. You understand? They don't actually have one particular definition. Now, an electromagnetic wave transports its energy through a vacuum at the speed of, these are the points you need to note. Electromagnetic waves. Number one, requires no medium. Being formed by vibration. You know, if I'm to be your examiner or your tutor that took this course, and if I'm to give you a test or an assignment that, okay, write for me what electromagnetic waves entails. Number one, you have to tell me that it requires no medium for what? Waves to be what? Transferred. It is being formed based on the vibration of what? Electrical charge or electrical charges. You understand? That's from the source point. The third point is that based on what we said the other time, electromagnetic wave moves through a vacuum or is being transported through a vacuum at a speed of 3.00 exponential what? 8 meters per second. These are the major properties that are being what? Exhibited by what? An electromagnetic wave. So a lot of other properties are involved. Do you understand? Now, a speed value commonly represented by what? Your symbol C. This speed value is being represented by symbol C. That is the speed of wave. You understand? That's the speed of what? Electromagnetic wave. So at this junction, these 3 to 4 properties of waves are giving us, 3 to 4 properties of your electromagnetic waves are giving us the in-depth knowledge and the in-depth understanding of what electromagnetic waves actually mean. Now let's go to the types. Types of what? Electromagnetic wave. We have number 1. We have what we call your radio waves. What do you use radio waves for? Listen, it has the longest wavelength of all electromagnetic waves. Number 1. All types of what? The electromagnetic wave. Your radio wave has the what? Has the longest wavelength. That's what we call longest wavelength. Remember, in our wave calculations, that's what we call lambda. This thing is called lambda. Now, this lambda is denoted as what? Is known as what? Wavelength. This lambda is the scientific name. You get? We call it what? Lambda. This is the scientific name. But the actual meaning is wavelength. You get? So out of all the types of waves that exist under electromagnetic wave, your radio waves has the longest. You understand? Has the longest wavelength. And I say wavelength. Wavelength is wavelength. If this is to be your wave, this wavelength is, the length to cover one particular. You understand? If it starts from here, stops here. This is one wavelength. If one starts here, you understand, goes this way. But if okay, excuse me. If one wave stops here, stops here. Another one goes like this, stops here. So this is another wavelength that way. So if you calculate the total number of wavelength for your radio wave, it has the longest wavelength. You understand? Per column of a particular wave, among to be compared with all other types of what? Electromagnetic wave. So if we are to now look at what is now this wavelength, wavelengths are often used to transmit data. Here again, and have been used for all sorts of applications, including your radio, your satellite, your radar, and your computer network. Let me now bring it to the practical sense. In your locality or area, there is this big mast. We call it mast here in some call it mast or something. They call it mast. Now it's being built by telecommunication companies. It must have been built in your area, whether it's MTN, Airtel, or whatever. They will label it on the body and they will build a fence around it. Now this mast has what we call receiving ports. Now this receiving port, what do they do? All they need to do is to connect your phone. If you are to make call from here, you understand? Let's say this is your phone now. They connect your phone. They connect it to a satellite back in the atmosphere. Now, if you are to call, let's say from Nigeria now, you want to make call to USA. This is what they do. This is what the mast is meant for. The mast, immediately you put through your call, the satellite will help to connect the signal of your phone. It helps to connect your phone to the satellite. Now, the satellite will now decode. Let's say if you are calling USA now, USA's number start with plus, let's say +1, 2, 4, whatever. Now, this code makes the satellite to decode the country. you are calling. So immediately this satellite decodes the country you are calling to now send to another mast of USA. So it is the mast in USA that will now locate the remaining number. You understand? Which will now connect to the person's phone. From there, the phone will ring. All these activities, they occur within 0.9 seconds. That's why if you make a call now, before 1 second, the other recipient's phone will ring. You understand? So that's one beautiful thing about what radio waves. What you're actually doing here, what the waves that is actually being used to interconnect your phone and your mast is what we call your radio waves. Hope you get it. So this is an example of what? A very good radio waves. It is the radio waves you use to connect phone. It also allows your network. Most of us will normally complain, I wake up in the morning, I just discovered that my phone's network has gone. You know, we used to have something like this, we call it bar. If you notice it at the screen of your phone. Now if the bar on your phone is just 1 bar or 2 bar, it means that there is no signal. What is actually happening is that probably the mast that is in your area that is actually carrying the network, maybe the receiving port there got faulty, or probably there is no gen to power the mast. The mast is somehow down. Everybody that is closer to that particular mast will be enjoying. Will be experiencing low network. You understand? Those are the little things. Now the mast might even be powered, but something might have happened with that mast. It is